All right, guys, I still don't see any questions related to week number 6 lecture on the Google Doc. So I presume either you're still catching up, in which case you might be a little bit behind, but I'm more than happy to discuss any questions on the fly about the lectures. So since I got office hour at 4 p.m., so I will restrict maybe the session here only to lecture materials. And then if you got questions related to lab, I'm more than happy to answer you maybe during my office hour today at 4 p.m., 4 to 5:30 as usual. Okay, so do you have any questions related to lecture number 6? You can just refer to the slides, notes, or any questions. You don't need to get prepared on the Google Doc. That's okay. So I can take your question. It's really the time allocated for you. Any questions about lecture number 6?
Hi, Jackie.
Hi, Robbie. How are you?
Good. How are you?
Very good. Very good. Robbie, questions, please.
Yeah. Will inheritance be on the quiz this week?
Well, so which topic are you talking about? Well, what topic on the quiz?
Inheritance.
Inheritance?
Yeah.
Okay, so let me be precise to Robbie's question. So Robbie's question was, will inheritance be on the quiz this week? The answer is yes, but let me be precise over here. So if you guys go to the lectures, okay, you can see there are week number 6 and also week number 7. So officially week number 7 only starts tomorrow, but if you want to get ahead, feel free, okay? So what about for lecture number 6, for quiz number 6? If you go to this lecture over here for inheritance, so these are the stuff you will have to know. So you can see for the inheritance over here, we basically talk about mainly just the first 2 learning outcomes about how you can do code reuse and how you can do design without the inheritance, and what will be the criticism on that. Especially, let me draw your special attention. So we talk about some running example over here, the student management system, a simple one. And then we talk about basically several keywords that we introduce, which you definitely got a correspondence in Java and other OOP as well. So we first start with the design without inheritance. We talk about 2 of them. So please make sure you go over them to understand what happens if you don't have inheritance. What design principle would you violate? And then let me show you over here. And then the main problem we are trying to solve is you want to have a list of students consisting of resident and non-resident students. Want to have different kinds. So that's kind of the main design problem we are solving. So you really want to dive into to see how we can solve it. So there are 2 keywords you want to pay attention to. Number 1, the inherits keyword, but you pretty much saw this already from the previous lab. I just didn't write it yourself, so you want to get used to it. Another one you want to get used to is about the, there are 3 keywords. Number 1, the inherits. Number 2, the redefine keyword, okay? And number 3, over here, about the use of precursor. So the use of precursor is similar to how you use it for super keyword in Java, say, right? So just about how you can reuse the code inherited from your immediate parents. Okay, so that's about basically just about what you have to study for quiz number 6. And next week for quiz number 7, we'll cover something more. So Robbie, does that answer your question?
Yes, thank you.
No problem. Okay. Amir asked some question over here. What if in the abstract UI, we need to interact with the user to ask more questions? For example, in the bank machine, after user enter withdrawal values, then we want to ask them which account? Okay, I see what you mean. Amir's question is very good. Okay, let me try to do the following illustration. Let me, guys, let me just get prepared for this. I think it's a very good question here, but I just need to need a little bit visual to help me answer better. Okay, so remember this diagram here. Okay, let me just make a copy of this, and then I'll switch to iPad and I'll answer Amir's question. Just bear with me a few seconds. I'll get prepared. Okay, let me switch to my iPad. Okay, guys, you can see my iPad here. So let me repeat Amir's question just once more. His question was, basically thinking this way. So this physical interface, as you actually learned from the lecture, it's called a concrete user interface. And concrete user interface can be physical or it can be software interface, like a mobile phone or for desktop or for the web, etc. So it's just concrete. It's fully functional. And Mia's question goes like this. What if somehow we want to interact with the user with a more complicated sequence of actions? For example, let's say this. Imagine that when you are interacting with a concrete user interface, how would you do it? For example, you might say you will touch the screen to start with, and then you have to insert your bank card, right? You say, for example, touch the screen, and then insert the bank card. It is similar to what I illustrated in the lecture. And then after that, you will key in your PIN, right? And also, you're going to choose to say, I want to do, for example, withdraw. So Amia's question goes like this. Let's say after I select, I want to do withdraw, and then the screen actually display which account you want to withdraw. For example, you may want to withdraw from either the accounts associated with the bank card or maybe another account, for example, right? So in that case, maybe you will do something on the keyboard to really enter the input. And then I'll just say some keyboard interaction. And then after that, you will do amount. Think about all these action sequence over here. So this is the interaction with the concrete UI. Interaction with concrete UI. And notice one very important property for these interactions over here. So they are asynchronous. Asynchronous simply means they don't really happen simultaneously. Sometimes you have to really touch the screen before you can insert the card. You have to insert the card before you can key in the PIN number and etc. So these all happened, let's say sequentially. So they are kind of asynchronous. So now, how does abstract UI help us on that, right? So the abstract UI is going to abstract all the entire sequence into a single event in the in the abstract UI, the grammar. So now everything here will be abstracted here as one single event. I can simply say just withdraw. And now the withdraw over here, I can say maybe I have the ID for the accounts. And also I have the amounts that's also integer or real number. So I only got two inputs over here. You can think about when we say abstract UI, abstract because we filter out many details, especially about the timings that's actually interacting with the real GUI over here. So that's why abstract UI is actually can facilitate your fast development for your prototype. So the response to Amia's question is, how do you handle such interaction in the abstract UI? The answer is you don't really handle such timing or such complicated sequence in the abstract UI. You don't really do it. So you can think about as far as the withdraw function is concerned, think about after interacting with the concrete UI, what kind of information will you get in order to perform the withdrawal transaction? What you will get is you're going to get some ID for the account you want to withdraw from, and also the amount that you want to withdraw from that particular account. And then, so this single event is going to represent this entire complicated sequence. And one more thing to say. In real life, the sequence of actions you actually interact with the concrete UI, there might be many kinds. Exactly how to transform that into the abstract UI, that will be another design challenge for you. But for the project and also for your lab number 3, we simply just give to you the abstract events already, so you don't have to worry, right? But in this case, the withdrawal really abstracted a very complicated sequence that's actually synchronous. Okay. Okay, Amir, sounds good. Okay, just want to make sure. But I think, Amir, I think it's very good concern over here. So think about the abstract UI over here. For your convenience of fast developments, think about the abstract UI is actually synchronous. So everything happened at one go. Asynchronous, okay? That's kind of like a contrast. So Arjun, you have a question for lab 3. As I said, I would rather dedicate this time for lecture number 6 because this might be the only time left for your fellow students. So if you really have questions about lab 3, my office hour will start at 4 p.m. You're more than welcome to come, and then I can dedicate the time to you for lab 3. Okay, thank you. Thanks for understanding. Okay, guys, any more questions? I can pause. I know you might be still catching up. That's understandable, but I'm here, so you can ask me any questions you like regarding the lecture. Okay. Amir asking, how do we decide between composite and inheritance? So what do you mean by composite? Is there a particular slide you're referring to, or? Beside, okay, I might see what you mean. So you're basically saying, when should we use inheritance for code reuse? Okay, I would say, to be more realistic, this might be what this might be the actual scenario for your design activity. Okay, let's see this. So let's say you are now doing your version 1 of your design. Okay, let's say somehow for version number 1, you actually get maybe, let me be a little bit symbolic over here, right? Let's say you have class, maybe A, and then you have another class, B. Okay, let's say somehow you thought they should be separate classes, which has nothing to do with each other. There's no inheritance just yet. So Amir, what you meant by composite is you might have many features in A and also many other features in B. For example, you might have some feature A, B, and C, okay, and also D, for example, right? And also you might have other maybe E, F, and B, and then C. Let's say we got 4 features in each class, right, conceptually, okay? Let's say you do your developments and then you make things to work, right? Let's say up to here, you just get to the point that everything is working. So the main message I want to give to you while you're doing your lab number 3 and also the projects, you don't have to be so mean to yourself by expecting your very first version of the design is actually perfect. It cannot be the case, right, in general. So feel free to be a little bit of inefficient in terms of your design, which means maybe you don't really support inheritance in the first place, but maybe after you have got some working version for your design, you can now refactor into by introducing inheritance. Let's say in this particular case, right? So you realize for class A and B, even though they're different classes, but you realize B and C over here somehow overlap with the B and C over here. So the B and C here are simply just features. The features can either be attributes, can be a routine, which means can be either a command or a query. So somehow you can see A and B over here share many, at least something in common. In that case, you got some duplicates, right? So as we learned before, whenever you got duplicates, so that means you're going to violate the single choice principle, right? If you violate the single choice principle, that's not good because that means your design definitely deserves some improvement. So now what you can do is you can now try to refactor your design, right? Refactor. So the term refactor here really means without changing the behavior, behavior of your software. Improve its architecture. Improve its architecture. So the key term over here is really about without changing the behavior. Okay, behavior doesn't change, but you only want to improve the architecture. Okay, so that's what refactoring really means. Okay, it's a very common term. Okay, so now how can we improve it? What you can do is maybe now I want to somehow put B and C, so these two features into a common place, like a single place. So what I can do is I can now introduce a new class over here. Let's call that maybe just call it Z, for example, right? In the class Z, you can actually put B and C over here into a single place, and then you can introduce the inheritance relation. And then you can see, for example, one class here and one class here. You got A and B. And now you got, for example, A and D. So these are specific to class A. You got E and F. So these are specific to class B. And then for B and C over here, you got flexibility. You can think you got different options over here. So option number one, you can simply say B and C are simply declared to be deferred, in which case you will have to make B and C effective. You have to give some version of implementation over here, B and C. So that's option number one. Option number two would be something like this. Let's say you have some default implementation that's already implemented. Let's say it's option number two. So B and C are both effective in class Z, the common superclass over here. And then you can decide maybe for class A over here, I will simply inherit B and C, the default version verbatim. On the other hand, for class B, I can say over here, I can say B++, meaning that I'm going to redefine the behavior. Maybe I'll partly reuse the code that's inherited from Z, and also for the other part, I'm going to redefine the behavior, right? And C++, like that. So that's more like a refactoring process for your design, okay? And you actually got a concrete example for your lecture. So let me, if you haven't gone through it, let me show you where you can find it, okay? If you go to your, again, the lectures page, let me show it to you. So if you go, let me just show you the iPad notes over here. I tell you which page to look at. So that's not the ETF part. So if you go here, when we start talking about inheritance. So that's the first attempt, basically, okay? You can see over here, we're having non-resident students and resident students. So these two classes are completely independent of each other. So in that case, that's the first design attempt. And we realized we got lots of code duplicates, which violates the single choice principle. That is why eventually we want to factor out everything that's duplicated. For example, you can see the tuition. You can see this part here about calculating the base rate is actually duplicated. So we can factor that out into a common superclass, okay? So that's the part you want to maybe review for your lecture number 6. Okay, Amir, does it make sense? Very good, all right. Very good, I like the question, that's nice. Okay, guys, you can definitely keep coming, the questions. If you're still thinking that's okay, I can wait for you, okay? Let me just fix this a little bit. And feel free to speak up if you wish. Another question from Amir. How do we ensure in the clients will use proper class? For example, it will use resident students and not non-resident students, or is it not our responsibility? Interesting question here. Let's say this. So you're basically talking about we are the supplier, right? So let's say we are the supplier. And you're talking about clients, let's say, assuming that client is simply somebody else, maybe not our part of our team, or simply our customer, you know, wherever. Okay, let's say from the supplier side, we simply got, let's say, we got students, and then we got inheritance over here. And then here we got resident students, and we got non-resident students, for example, okay? So you're basically asking about this. What if clients actually instantiates the wrong type of objects for the students? Should that be our responsibility? Okay, my short answer is no, it shouldn't be. So what we have to make sure as a supplier, we want to make sure we actually implement each feature in the non-resident students and resident student properly. For example, especially for a resident student, you got premium rates and also tuition. So tuition should be redefined properly by using the premium rates. And also for non-resident student, you got discount rate, and also tuition should be also redefined accordingly, right? That's the only job for us as a supplier. So now for the clients, let's say they do this, right? Let me just give you some scenario over here, which let's say if the client declares S to be of type students. Okay, so now let's say somehow this is how the client is trying to initialize the objects. Let's say they say creates non-resident students, okay? So this is a dynamic type. By the way, so this is something that you will have to study the next week. So for this week, it's not really necessary. But since Amir asked the question, so I just use this to explain. So if I say s make, you know, with some argument value over here. Okay, so now let's say later on, if the user, the client simply say s dot set discount rate, for example, 0.75. Apparently, this code is problematic because you can see, even though it is dynamically pointing to an NRS students over here, right? Even though it is the case. However, this particular S here has the static type students. So now in this case, you just cannot call this. So this will not be allowed by the compiler. And this is the principle about imposing expectation on the static type. So this is something you will learn. Maybe you learned it already from the previous OOP course. So Amir, this is just one example where the client is simply just using, not really using the class properly. Okay. Another example, let's say this: if the client really try to instantiate this one into NRS, but now they might say s dot premium rates, right? So this one here, if they're really meant to do premium rates, but they only instantiate that to be an NRS, apparently that's their mistake, not ours. So back to your question, our job as a supplier will be to implement every individual feature of the inherited feature and also to really get the architecture right. That's our responsibility. For clients, if they simply use the classes in the wrong way, that's their problem, not ours. Okay. Yeah, about the export status, of course, for the supplier, you will have to decide, which for each feature, which one should be exported to which client. So that, of course, that will be the supplier's responsibility, right? So we talked about export status already in the previous week. So here, supplier. So number one, you have to make sure you implement the features correctly, and then you also have to properly document the API for your features. Documents and contracts will be the most precise way to actually document your class. And number three, you may want to think about, like what you mentioned, about export status. For example, maybe for the tuition, should it be open to the public or should it be open to maybe other classes, right? So that's definitely some concern you want to think about. This is not required by your lab number 3, but maybe for your projects, which we're going to release sometime early next week. So you got 5 weeks to do your projects. For your projects, later on, you will have to justify your design decision. So as a supplier, you can definitely try to think about how you implement the features, and also about contracts, and also about how you design the export status, or also about how you maintain or how you satisfy all the design principles. Okay. All right. Okay, I'm waiting for the next question. Okay. I would say, luckily, your lecture series number 6 this week. The first part is about ETF. The second part is about just about the very easy part for inheritance, about code reuse. So I think even though a little bit behind, but that's not really disastrous. So hopefully you'll be doing okay for quiz number 6 this week. But for quiz number 7, we'll dive deeper into the inheritance. So please make sure you don't fall behind for your lecture series number 7. Okay, guys, any more questions, please? You can just speak up or type on the chat.
Sir, I have a question.
Go ahead, please.
The ETF project. When we use the ETF command to call some feature or routine in the model, do we actually only can use the features from the model class or whatever routine in the cluster?
Yes, that's correct. So Jaha's question, conceptually, yes, for ETF. You know what? Let me rather than rejoin from scratch, which I'm happy to, but it may not be so pretty. So let me just get to the diagram and then we'll talk about it. I will rephrase Jaha's question in just a moment. Let me just get the appropriate picture. So if you go to the ETF lecture over there, So this is diagram. Okay. Okay. Let me just copy this diagram over here and now speak about it on the iPad. Okay. Okay, let me move this away. Okay, bear with me. Okay, so this is diagram over here. So Jaha's question was this. So let's say when you are trying to program your lab 3 or your project just in general, or whenever you're building any prototype using the architecture like this, you definitely have to do something about the ETF commands over here, right? Let's say the back example, right? So there are two things you want to do. Number one is about error handling. And then number two is about to call the relevance model operations. I believe that's the term I use in the tutorials, videos, and also in the lecture slides. Okay, so I believe Jaha's question is more concerned about number two over here. Okay, so what do I really mean by calling the relevant model operation? Let me be more precise over here. If you want to think more about how the singleton pattern is really being instantiated in your ETF projects. So we say that in the ETF commands over here, we simply got model by default. It's simply declared to be of type ETF model. Okay, number one. Number two, and also in the make, in this particular ETF command, we actually got, for example, local, and we got model access, which is of this particular type, ETF model access. And then the way we get this model over here, we say model is assigned to ma.d, ma.m. Okay, so that's something you know already from the previous week's lecture. So that's how the singleton pattern is used. So now in every effective class for the ETF command, so now how do we call the relevant model operation? So we'll simply say model dot something. Okay, so in order for this particular routine to really be valid or to compile, so that means you can think about the ETF model over here is really the entry point of for your execution, right? So let me think about single entry point for ETF commands to work with. So now, what feature do you actually declare in the ETF model is completely up to you. For example, if you declare F1, F2, F3 over here, of course, over here you can call F1, F2, or F3. It might be possible that, so one thing you want to really avoid for Lab 3 and also the project, you want to avoid the following. You want to avoid having a Superman module. I think I talked about this term already when we talk about modularity in week number 2, I think. Superman module. That's something you definitely want to avoid. You want to have, you don't want to have a single module over here, maybe just ETF model. Maybe you rename it to something that more closely reflects, more accurately reflects the application you're developing, maybe bank, or maybe game, or maybe board, or whatever, right? You want to avoid having a Superman module where you simply define every feature over here, F4, F5, F6, everything. You don't want to put everything together into here. So this will really violate the cohesion principle. It will violate the cohesion. So to really satisfy the cohesion principle, you want to have modularity. So what you want to have is, rather than having just a single class over here, what you may want to have is, maybe you have class A, and class A has a client supplier, maybe to class B. And class B over here has a client supplier to class C. And then at the same time, maybe class B also has some inheritance with another class, maybe D, right? So that's kind of the freedom you get in order to design your classes. And now, what features can you call from the model here, from the ETF command? Whatever dot notation that will be reachable into the model cluster will be able to call. For example, you might say model. Let's say, for example, let's say you have already renamed this ETF model into A, for example, right? Let's say you already rename it. So now A is a single point of interaction with the abstract UI. So now if you say model is going to be of type A, let's say, you already rename it. So if I say model dot, so now apparently according to the architecture over here, I can definitely navigate to class B by some supplier. Let's say the supplier name would be, for example, maybe supplier will just be B, right? I can say model.b. And then once I get to this particular class over here, there might be some other feature, for example, F3. And then I can say F3. So this is definitely some feature call you can make in the context of every ETF command class, right? So that's kind of the freedom you have. So once you are pretty sure about the architecture for your model cluster over here, having as many client supplier, having as many inheritance relation as you think necessary to really reach modularity, and then from each of the ETF command classes, all you got to do is to use the dot notation to really navigate through them. So that'll be the overall picture. So Jiahao, does it make sense to you?
Yes, I also have another question about the first one, the error handling.
Error handling, okay, go ahead.
Yeah, since the error is actually about the model, right? Dealing the error for the comment, and actually there will be some related attributes or routine in the model. Is this following the cohesion for the model?
Yeah. Okay, so your question basically is about for error handling. So so when I say we'll do the error handling in this particular class over here, to be more precise, let me just show you the slides. Maybe you have looked at that already. So let me bring back the slides. So the kind of error handling you should do is something like this. For example, in one of the ETF command class over here, right? So this part over here is the error handling. You would say if something is true about the model, then I will print out some error message. If something else is actually true about the model, I'll print other error message. It's only when we get to the else part, meaning that all the error conditions are actually false. In that case, I can call the relevant model operation, right? So that's what the error handling I was talking about. More to it, you can see over here, we say to set some error message and also to set some other error message. You want to be sure about this, right? Let's say, for example, so we still talk about this Superman module business over here, right? If it turns out maybe there is a set of feature in your model class, in your Superman module, maybe they are related to maybe error messages, for example. In that case, maybe there's another two, for example. Let's say these two are to do, let me use a different color here just to distinguish. Let's say F4 and F5 in the same class, but they are to do with maybe transactions, maybe withdraw and deposit. So now what you want to think about for your design choice, you're basically putting under the same class functionality related to transactions and also functionality related to error messages. They are not really relevant to each other. So in that case, putting them into the single place will be violating the cohesion principle. So you may want to think, you may want to consider factoring out the error messages related features into another module. So that's one comment for you. Jiahao, does it make sense?
Yes, that makes sense.
All right. Okay, let's take a look. Parthiv asking a very good question there. How do you make ETF? At some point in the lecture, I told you that if you don't have any framework like ETF, you need to make one. Let's say after this course, you go back to maybe Java, you go back to Python, you go back to somewhere else, right? So you will definitely need to look for, well, let's say for your rapid developments, right? Maybe your company actually supports a framework like an ETF. Well, maybe your company supports like an ETF-like framework in Python, in C# or in Java. In which case, again, you don't have to worry about having to deal with the concrete UI when you are developing your code. In that case, you can definitely just follow their framework. If they don't have such framework, In that case, I would say it will be up to you. So either you can build a framework like this from scratch, in which case, if you're interested in building such a framework yourself, you can speak to me. I can give you some insight into building such framework. You will need to have some knowledge about compiler, okay, which I don't want to bother you right now because that might confuse your fellow students. But such framework is actually very valuable. But if your language doesn't support this, you just need to build one by yourself. Okay. Okay, so Arjun, are we allowed to make our own classes from scratch? Yes, definitely. So to be more precise, in the model cluster over here, what you're given by default is simply just an ETF model and ETF model access. So what I recommend you do is you want to rename, number one, rename these two classes into some names better reflecting the nature of the application that you're building, right? Either for Lab 3 or for the project, number one. Number two, you may not want to have only a single class which will do everything. So that will suffer from the Superman module problem, okay? So what you really want to do is maybe decompose this particular Superman module into several classes. So that's the modularity design principle that we talk about in week number 2, all right? So you're definitely allowed and you're actually encouraged and you should develop your own classes from scratch for sure. Okay, any more questions? Robbie, let's see. How should we decide where and we should add our pre and post conditions? Should we repeat pre-post condition? No, you don't have to. Okay. Let me simplify this a little bit. Okay. Imagine that this is the model cluster. Okay. Thinking this way, think about the model cluster is like the project that you were given in lab 0, lab number 1, and lab number 2. So what we really try to emphasize in the previous lab, before lab number 3, before the ETF, is for every routine, for every query and command, you should really think about a pre and post condition. So I would say, let's only talk about the model cluster, and then I'll bring the abstract UI into the context. Just, okay, let's talk about model first. So let's say if I got, for example, deposit and withdraw. Let me just use a bank example, right? If I got a deposit with some parameters over here, and of course, part of your design decision will be how many input parameters should I take for the routine. I'll leave that to you. And then you should also think about the contracts. What should be the precondition for this deposit, and what should be the post condition for this? Ensure, and then this, right? Okay, so I would say as far as the model cluster is concerned, think about whatever you are developing here inside the model, you should follow the similar style that we did for the previous lab number 0, 1, and 2, which means for every routine, you should really think about what kind of contract I should really write in order to, when something goes wrong at the runtime, either when there's a violation or when the when the output behavior is simply not as expected, in which case I will hope maybe my post condition can really help me catch the error, right? So that's really the benefit for design by contracts. Let me emphasize that first, okay? So design by contracts surely should be imposed, also should be emphasized in your model cluster. So now the confusion might come from here, okay? So now let's say in the case of your rapid prototype development, let's say when we talk about over here, rapid prototype developments. This is to say that once I'm done with my model, I would like to try to see whether it's going to work when I try to interact with my user. But I don't necessarily have to build a physical user interface like this. I don't have to. That would be too time consuming to actually do it before I can test my code. I definitely don't want to do that. And even though I don't need to do it by myself, but for some hardware engineer to really build something like this, you have to wait for them. You don't want to rely on their progress on this, right? So that's why in order for the rapid prototype development, we will actually use the ETF, which will give you some abstract UI. Okay, so let me bring the ETF into the context. And then I'll try to say beyond the ETF, how can you still make use of the model? So for the rapid prototype developments, you're simply just going to make some connection with the abstract UI. User commands, basically. I'll just say abstract UI over here. Okay, and then you got the ETF commands, under which you got the various different command classes, right? And also you got the client supplier over here, okay? So this will be the model. Okay, one thing to note, okay, one thing to note. You're basically saying the following. Number one, the abstract UI of the ETF depends on the model. And number two is actually very important. It's kind of implicit, okay? Number two, the model does not, okay, negative, does not depend on the abstract UI. So what do I mean by that for point number two? In your diagram or in your ETF projects, you should never ever see any client-supplier relation that will come back over here. For example, you might say maybe some class of my model over here actually has a supplier who is ETF command, for example, right? This should never ever be allowed, okay? So this is something that shouldn't happen. So point number one is saying for this particular abstract UI that's generated by the ETF, the only the simple way to really make connection to the model is by declaring model in the ETF command. So that's how we make connection. So every time if there's any user interaction occurred in each of the commands, we can simply call the relevant model operation. That's how we test, right? Number two, the model cluster itself does not depend on this particular abstract UI cluster. Why? The reason is, so let's say you have done lots of regression testing, you have done lots of scenarios for the acceptance test, you're done with all the tests, you're happy right now, right? So once you're pretty sure you're okay, so now you can actually do two things, right? I'll just show you two possibilities over here. So number one, let's say, so now after thorough testing, so after thorough testing, there are two things you can do. Let's say A, you can actually build some concrete build some concrete UI. Build some concrete UI and import just the model. In that case, what you will do is you will simply say, the model has been thoroughly tested using the abstract UI cluster, right? The abstract events. So now we can simply just use this model directly and port it into the concrete UI. So you can think about, in this case, the abstract UI will just be abandoned. They are not useful anymore, okay? Assuming that you have thoroughly tested your model, okay? That's plan A. Plan B, okay? You can also include the model as a library module. Well, pretty much like in iPhone, in Java, in any language, you always got people contributing to the community about their own library module. Maybe a module for maybe socket programming, maybe a module for reading the XML and to parse the XML, or a module for maybe taking C program input, right? Things like that. So this will be, but for this to work, you also just get only this module over here, whereas you can simply ignore this part over here. So that means if your original module over here actually rely on the abstract UI, in that case, you simply just cannot import this independently to any of this because it still depend on the abstract UI, right? So that's why you shouldn't have any dependency going from the model into the abstract UI. So that's the main point I'm trying to make. So one more thing I want to say. So if we only got require and ensure that decide by contract as usual in the model, right? So what should we do in these classes? So what you should do is for every model operation that you might call, which has some precondition over here, you want to have maybe just the corresponding error message, right? So in that case, it can let's say if I say require P, let's say some predicates, right? I can say if it is not the case that P is true, in that case I can put some error. So this error handling is only for the purpose of the abstract UI. But later on, once you switch to maybe the concrete UI, so these will be obsolete. So you don't need to do that anymore. But maybe you still need to do your own error handling, maybe in the concrete UI later. But it's not outside the scope for your lab and the projects, right? So Robbie, so one more recap of a short answer to your question. You want to make sure the model itself is completely independent of the abstract UI. It's only the abstract UI that's trying to use the model. And then you want to practice the side-by-contract as much as possible, okay? So Robbie, does it kind of make sense to you? It's a long answer to you, but I hope that makes sense. All right, okay, anyway, so any more questions? Okay, I'll pause a little bit longer. If you guys are fine, and maybe we can have an earlier finish for the session. Anyone? I still have office hour today, 4 p.m. and also like an office hour tomorrow. So if you can only finish the recording and the lecture materials only tonight or tomorrow morning, you're still more than welcome to maybe consult with me about any lecture related questions tomorrow in the office hour. That's you're definitely welcome to. Okay. Yeah, Robbie, sounds good. Yeah, speak to me during the office hour, no problem. Yeah. Guys, any more questions about the lectures? Any more? I'll wait for maybe a few more moments before I need to let you go. What are my office hour tomorrow? 4 to 5:30 tomorrow. Monday, Tuesday, Wednesday, 4 to 5:30. Oh, by the way, we also got a TA schedule hours as well, right? So I'm gonna send you a reminder, but you can definitely, if you go to the lectures website, if you go there, as always, you can simply click on weekly lab schedule. So where's the labs? I think there was a link. I never came here. Over here, schedule labs. Okay, if you click on that, so for this week we got 4 different schedule hours for you. So you can definitely choose the one that you're that's convenient for you. So especially for these two, we kind of did a survey in the beginning of the semester, right? So I thought those hours are chosen by you, right? Okay, guys, it seems like you have no more questions about the lecture. Is that correct? All right, should I call it a day? Right, hopefully you will come a little bit more prepared next week for lecture number 7. I think for lecture number 7, it's a very thorough review on the inheritance because we do need those knowledge to really study the more design patterns for the rest of the term. So if you're behind for lecture number 6, catch up and don't get behind again for lecture number 7. Otherwise, you wouldn't be able to take advantage of the time I allocate for you. All right. Okay, I will see you later. And then if you got more questions, get in touch. Okay, I'll end the meeting now.